I'm Dr. Michelle Tai. I'm a senior research fellow working in suicide prevention at the Black Dog Institute, University of New South Wales. So I'm here to give a brief overview of my paper, which looks at the extent of spatial errors in suicide incident data occurring as a result of the automated geocoding process used by an Australian coronial data custodian. Looking at the geocoding accuracy of suicide data is timely. Over the past few years, there's been an increasing interest and investment in suicide data to identify areas which are high risk suicide locations, including hotspots, to understand where life saving interventions are needed most. However, identifying hotspots requires us to be confident that the underlying data is being given the correct X and Y coordinates for the location where that death occurred. So as a first step in examining the extent of accuracy or error in geocoding, we replicated what the data custodian does, which is to run the records through an automated geocoding software package and to see how many records match to a national address database. So we found that 28% of our cases couldn't be exactly matched to an address using that software. And the main reason why the software couldn't make the match was because many of those deaths were occurring at places where there was no clear street address, so places such as bridges or cliffs. So the team took that 28% of cases and manually reviewed them. So they manually reviewed the coronial reports and a range of other online resources to identify the correct location. So by adding in that manual review component, we were able to improve geocoding accuracy from 68% to 95%. And the main issue with automated geocoding is that if the program can't make a match, it will assign that record geocoordinates for the nearest central kind of fallback location. And that might be the middle of a street or even the middle of a suburb, depending on how much data is missing from the address string. As a result, the location of that suicide could end up being many kilometres away from where the death actually occurred. And that's what you can see happening behind me here. So the red clusters are the clusters that we were able to identify based on our manual review process. So we have confidence that they represent the accurate location in which the deaths were occurring, whereas the blue clusters are what we would have identified if we just solely relied on the geocodes provided through the automated geocoding process. And as you can see, those clusters are not very close to each other. And normally we would probably implement structural means restriction interventions at the blue cluster, because that's what we would have relied on in terms of data from the data custodian. But as you can see, if we implemented structural interventions there, they would be unlikely to be saving lives. So we can conclude from this paper that suicide deaths which occur at non-residential locations are not being accurately geocoded. And what that means is that we could be falsely identifying hotspots. What we're hoping with this paper is that it raises awareness of this issue for those who are working with similar data sets, particularly for those who are analysing the data with the intent to develop suicide prevention interventions. Thank you.